Hello everyone, welcome back to our channel Statisticians Hub. Myself Akram Birab Singha, a student of MSc 4th semester, Department of Statistics, Assam University, Silchar. In this video, I am going to discuss how we can fit binomial, Poisson and normal distribution in Python. So without further delay, let's start. Example, 7 coins are tossed and a number of heads are noted. The experiment is repeated 128 times and the following distribution is obtained. The data is given below. Fit a binomial distribution assuming the coin is unbiased. Now let us see the PMF of binomial distribution. The PMF of binomial distribution is given by P of x equals to NCx p to the power x 1 minus p to the power n minus x. The mean is NP and the variance is NP multiplied by 1 minus p. Now let us see the Python codes to fit the binomial distribution. The first 3 lines are used to call the required packages for fitting. The first package NumPy is used to perform the mathematical operations. The second package binom is used to calculate the estimated frequencies. And the third package matplotlib is used to plot the graph of observed frequencies and expected frequencies. Next, we have to assign the given data using arrays for fitting. Next, to fit the binomial distribution, we have to define the length of the data. Here we will not count the 0 as success, so we have to minus 1 from the length of the data. Next, we will calculate the parameter p using maximum likelihood estimation using this code. To estimate the required frequencies, we will use the package binom and multiply it by the sum of the observed frequencies. And then we will print the estimated frequencies. At last, we will plot the observed frequencies and expected frequencies in a graph using this block of codes. Now we type all the required Python codes in PyCharm and let us see the output. Here we can see the observed frequencies and expected frequencies in this graph. Here in this graph, the red line represents the expected frequencies and the purple bar represents the observed frequencies. Next, we can see the expected frequencies in this output window. So now the binomial distribution is fitted successfully. Now let us see the next example. Fit a Poisson distribution to the following data, which gives the number of dots in a sample of clover seeds. The data is given below. So let us see the PMF of Poisson distribution first. The PMF of Poisson distribution is given by P of x equals to e to the power minus lambda to the power x divided by x factorial. The mean is lambda and the variance is also lambda. Now let us see the Python codes for fitting of the Poisson distribution. Just like the previous example, here we will also use the same 3 packages, namely NumPy, SciPy and the matplotlib. Here instead of binom, we will import Poisson. Next, we will assign the given data using arrays. Next, we will fit the Poisson distribution using maximum likelihood estimation with the help of this code. To compute the estimated frequency, we will multiply the Poisson PMF by the sum of the observed frequencies and then we will print the result. At last, we will plot the observed frequencies and expected frequencies in a graph using this block of codes. Now we type all the required Python codes in PyCharm and let us see the output. Here we can see the observed frequencies and expected frequencies in this graph. Here in this graph, the red line represents the expected frequencies and the purple bar represents the observed frequencies. Next, we can see the expected frequencies in this output window. So with this, the Poisson distribution is fitted successfully. Now let us see the fitting of normal distribution. Example, obtain the equation of the normal curve that may be fitted to the following data. The data is given below. Now let us see the PDF of normal distribution. The PDF of normal distribution is given by f of x equals to 1 by sigma root twice pi e to the power minus x minus mu whole square divided by 2 sigma square, where the mean is mu and the variance is sigma square. Now let us see the fitting of normal distribution in Python. Just like the previous 2 examples, we will use the 3 packages. After importing the 3 packages, we will insert the given data like class interval and frequencies with the help of for loop and using this block of codes. Next, we will create an empty data list with the help of these codes to fill it with values based on class intervals and frequencies. After that, we will calculate mean and standard deviation. Next, we will define x and p to calculate the PDF of the normal distribution. After that, we will plot the required fitted graph using this block of codes. At last, we will print the mean and standard deviation of the given data. Now we type all the required codes in PyCharm. So let us see the output. Here we will type all the given class intervals along with its corresponding frequencies. So let us type one by one. So now we can see the fitted normal curve. And here is the mean and standard deviation. Therefore, for the given data, n equals to 1000, mu equals to 79.945 and sigma equals to 5.598. So the equation of the normal curve fitted to the given data is as follows. With this, the normal distribution is fitted successfully. And here is the reference data used in this presentation. Here ends my presentation. If you like this video, give a big thumbs up and do subscribe our channel Statisticians Hub for more such informative video updates. Thanks for watching. See you in the next video. Bye.